Hello, and welcome to the webinar. My name is Tony Carew, and I'm the Digital Manufacturing Portfolio Manager for the Delmia brand of Dassault system. And today I'm going to talk about the main business drivers for adopting robot simulation. Do you use robots in production and wonder if robot simulation is right for you? Are you programming and then reprogramming a lot of robots and want to know how simulation can help? Do you use simulation already, but are wondering, is there more to it than just creating simple programs? Well, sit back, and in the next 20 minutes, we're going to discuss some of the main business drivers that compel manufacturers and suppliers to use robot simulation. Today's economy is making a transformation into an experience economy. There are over 3 billion middle-class people in the world today. The global economy has grown past $18 trillion for industrial goods, and it continues to grow. Over 7% since the year 2000. Through the introduction of new technologies, new products are being introduced every day. Today, we're seeing an unprecedented diversity being offered in the marketplace, and new technologies in engineering and automation help make this possible. Today's manufacturing systems are under extreme pressure to deliver, and these manufacturing systems must deliver the highest quality products at the lowest price possible. They also need to be flexible so they can manufacture custom products with different versions or configurations to meet the variety that consumers in today's market expect. Responding to this consumer demand from personalization, businesses in this age of experience are ushering in a revolution of manufacturing innovation, transforming from mass production to mass customization, the proverbial one-off order. The digitalization of manufacturing brings new levels of collaboration, where 3D product design and engineering is paired with the 3D simulation of the production system to bring products to market. And this digital continuity spans from ideation to design to production and supply chain planning. It even reaches out to the product ownership. By embracing technology advances, such as 3D printing, Internet of Things, and robotics, with a mindset of continuous improvement and competitive agility, businesses can drive value, meet market demand, and deliver unique buying experiences for their customers. Before we dive in, let's quickly clarify what we mean by robot simulation. As a quick introduction, let's consider the question, what does robot simulation do? Well, in the simplest terms, it allows people to conceptualize their robot production in 3D. It lets you see exactly what the robot system looks like and performs like. Because it's leveraging the 3D CAD data, it allows companies to move their production engineering further upstream to coincide partially with the product design phase. Utilizing an expansive virtual robot library, users can engineer a production system by designing tooling and fixtures and then adding kinematics to them. They can analyze the relationships of each design to ascertain how well the designs work together by locating collisions and clearances. The simulation can compute robot reachability and compute the robot envelope. Robot simulation examines very closely the cycle time of a robot, a component, a machine, or an entire system, and provide the user with the ability to perform what-if scenarios of the production system. Robot simulation is a mathematically correct model to realize a machine's effect on space and time. It's the only place where users can compare the designs of the process, the design of the product, and the resources all in a single environment together before any resources are purchased or any system begins in the build phase. New technology trends are creating opportunities for manufacturers, and when these technologies are used together, we can collaborate and innovate like never before. Things like big data and device mobility are evolving our computing capabilities so that we can look at massive amounts of data. Cloud technologies allow us to examine, analyze, author, and document from practically anywhere there's an internet connection. Crowd computing allows a group of people with a common goal to operate on the same set of data to process it faster. All of these together, along with robot simulation tools, as well as other engineering tools in the enterprise, allow engineers to operate across disciplines. Silos of data are removed and a common environment is utilized so many professionals across the company can have access to a project and work alongside others to bring products to market faster while working on a single data source or single source of truth. This is one of the primary goals of Dassault Systems' 3D Experience platform. So, what are some of the main drivers of robot simulation? Today's manufacturing systems are under extreme pressure to deliver the goods. The challenges that need to be overcome when designing products and production systems simultaneously are significant, but they are not unsurmountable. Having the capability for engineers to access the correct data is key, especially when products are being introduced with an increasing number of variants. And along with all these variants of products comes an increasing complexity and flexibility of automation. The high cost of ad hoc engineering that happens on the shop floor needs to be eliminated to help contain costs. When multiple products are being produced, whether in a single site or across multiple manufacturing facilities, production standards must be created and utilized across all locations to manufacture products with the highest quality. So, what are the main impacts that robot simulation brings to a business? The most notable is it accelerates its time to market by validating the production system ahead of time. The second major impact that robot simulation has on a business is that it increases production by maximizing resource utilization and by offline programming the robotic system. The third major impact is it allows companies to standardize on not only best practices, but on best resources as well. Let's dig deeper into each of these and explain how robot simulation impacts the way we do business in manufacturing. Probably the most profound difference robot simulation makes on an organization is accelerating its time to market. By utilizing the 3D Experience platform, every engineer can easily find the correct data that they're supposed to be working with. And even more importantly, they're always working with the latest version and correct configuration of data. And this is due to the platform providing a single source of truth across the company. Anyone involved in the project can have access to the information that they need to accomplish their individual goals. Managing design changes is always a daunting task, and particularly when there's no common system to work within. Managing design and engineering changes is easily handled by making each engineer aware of what the specific changes are and when they occurred. The 3D Experience platform shows the engineer if any parts were added or removed, and then allows them to easily reconcile any part buildup, fastener data, or any changes made in the configuration of the product. Concurrent engineering happens across different engineering departments all the time. But what about within the same engineering group? One of the best ways to accelerate the time to market is to provide functionality that allows robot simulation engineers to work concurrently with each other on the same data set. And this significantly reduces the time needed to lay out, build, validate, and program a robot manufacturing system. Robotics and automation are extremely accurate and flexible. The trouble is that most of the time, automated systems are not fully exploited for their capabilities. A lot of capability gets left on the table and remains untapped. And this is mainly due to the fact that many companies don't have a vehicle with which to engineer the robotic systems. Robot simulation allows engineers to program robots in a virtual world while the actual robot is still in production, so they can simulate multiple types and brands of robots and end-of-arm tooling to select the best resource for the given application. A virtual robot work cell that mirrors the real production cell or a digital twin can also help companies prepare and execute plans for the next phase of production. They can modify processes virtually to find the right solution, and they can better plan for the implementation of a kit change or a changeover, which reduces the amount of necessary production stoppage. When using robot simulation, engineers can see what processes are consuming most of the cycle time and make adjustments accordingly to balance the workload across their resources. The simulation engineer can conduct reach studies and redistribute sealant, fasteners, or move pickups or drop-off locations in order to make the best solution possible. When using robot simulation, the virtual robot can be extremely accurate when it comes to robot motion and cycle time. This high degree of accuracy in the virtual model means there's no guessing when it comes to robot cycle time analysis. The cycle time of a single robot, a machine, or resource, the robot station, and the robot line can be analyzed to produce a highly accurate Gantt chart at each level. The result is a higher throughput and better utilization. The virtual robot simulation provides a higher level of confidence that the system will perform as expected and production rates will be achieved. Using robot simulation, engineers can evaluate tool designs and process designs and see how well they work together in the context of the manufacturing work cell. Robot simulation gives companies the ability to standardize on best practices. Robot simulation tools allow the user to search and compare end-of-arm tooling in order to make the best decision regarding resource selection. The virtual environment also allows companies to more easily commonize across resources, so there are less spare parts and spare tools needed on hand for maintenance. A virtual robot environment promotes creativity and allows engineers to think out of the box. It provides a virtual sandbox for engineers to try new things. They can present multiple solutions to a production issue and validate which solution fits the situation the best. And when working in a platform-based engineering environment, the best solutions are not just discovered, but they're stored where they can be reused. The platform provides a venue for companies to capitalize on best practices. And once established, these practices can easily be rolled out across a manufacturing plant or multiple facilities. As you can see, robot simulations with a platform-based approach, such as Delmia Robotics on the 3D Experience platform, can make a huge impact on business. It allows companies to accelerate time to market by validating production systems during the product design phase. They can increase production and maximize resource utilization with offline programming of robotic systems. And it provides tools to help standardize on and then reuse best practices regarding processes and resources, so they can be used from one product to the next. What will your next robot implementation look like? With the evolution of technologies in engineering and in automation and robotics, wouldn't it make sense to take advantage of all the technologies available today and plan the implementation virtually? Thank you for attending this webinar on the business drivers for adopting robot simulation. I hope you found it informative, and I hope it helped you better understand the value of robot simulation and a platform-based approach for production engineering. For more information on Dassault Systèmes, robot simulation, the 3D Experience platform, or to join our robotics community, please visit us at www.3ds.com. And if you have any questions regarding this webinar, you can email us at delmia.webinars@3ds.com.